Second kind here, solving a system of linear equations using the elimination with multiplication and addition. So on these ones, normally you have your equations in what's called standard form, with both the x and the y on the same side, your constant term being on the other side. Your goal is to make opposites either in front of the x's or the y's. It doesn't matter. What you want to do is look for the least common multiple. Since my x's have smaller coefficients, I would probably use my x's. And I think about, okay, the least common multiple of 4 and 3 is 12. I want to make one a positive 12, the other one a negative 12. Since my signs are already opposite, I really don't have to worry about changing any of the signs. So I'm going to take my top equation times 3, which is going to give me the negative 12, the bottom equation times 4, which gives me the positive 12. If my signs are already opposite, both of these numbers should be positive on the outside because I don't want my signs to change. If my signs are the same, one of them has to be negative because I need to change one of the signs. So multiplying this out, 3 times negative 4x would be negative 12x. 3 times 9y would be positive 27y. 3 times 19, let's see, that'd be 27, so 57. On the bottom, 4 times 3x is 12x. 4 times negative 4y is negative 16y. 4 times a negative 17 is going to be negative. 4 times 7 is 28, so I get 68 there. And now notice that I have a negative 12x and a positive 12x. That's what I want to have happen, is to have opposites in front of those x's so that when I add, they'll cancel out. So now I'm just going to add my two equations together. Negative 12 plus 12 cancels out. 27 minus 16 would give me 11y. 57 minus 68 would be negative 11. Now all I have to do is divide by my coefficient and I can have this solve for y. So if I divide by 11, y equals negative 1. Now, I want to find the x value. I don't have one of my equations solved for x, so I just pick whichever equation looks easier. I'm going to use the bottom one because the numbers aren't as big, so it shouldn't make any difference, but that one is the one I'm going to pick up. So I'm going to do 3x minus 4 times the y value, which we said was negative 1, equals negative 17. So 3x, negative 4 times negative 1 would be plus 4 equals negative 17. I have to subtract my 4, so 3x equals negative 21. Divide by 3, x equals negative 7. Now again, if I want to check my answer, I'm going to check it in the opposite one that I used down here. So since I used the bottom equation to find my x value, I'm going to use my top equation to check. So I'm going to take negative 4 times my x value of negative 7 plus 9 times my y value of negative 1 to see if I get 19. Negative 4 times negative 7 is 28. 9 times negative 1 is minus 9. 28 minus 9 is 19. Yep, it checks out. So those should be my solutions. So number 5, we're solving our system of equations by the elimination method. And if I look at this one, on my y's, my least common multiple of 3 and 6 is 6. So I can make this problem a little shorter than the previous one because in order to make opposites, I just need to multiply that top equation times negative 2. So on the top equation, if I multiply everything times negative 2, I'm going to have negative 8x minus 6y equals negative 2. Bottom equation I'm just going to leave alone. Technically I could say I'm multiplying by 1, but I'm saying 7x plus 6y equals 7. So you'll notice again in front of my y's this time I made opposites. One's a negative 6, one's a positive 6. So when I add my expressions together, they're going to cancel each other out. So negative 8x plus 7x would be negative 1x. Negative 2 plus 7 would be positive 5. If I divide by my negative 1, x is going to equal negative 5. I I found my x value. I need to find my y value. This time I think I'll use the top equation. The top equation looks a little easier than the bottom one just because the numbers are smaller. Not that it should make a difference. I'm going to take 4 times my x value, which we said was -5, plus 3y equals my 1, and solve that equation. So here I get -20 plus 3y equals 1. I'm going to add my 20. So 3y equals 21. Divide by 3. Y equals 7. Again, if I just want to quickly double check myself, 7 times the x value of -5 is -35. 6 times the y value of 7 would be +42. -35 plus 42 is 7. Yep, checks out. So number 6, we want to solve our system of equation. On this one, doesn't look like either getting rid of the x's or the y's would be too much easier than the other one. Again, I'm just going to do the x's because my numbers are a little bit smaller there. And so if I want to eliminate my x's, thinking about my least common multiple of 4 and 5, I want to have a 20. I want one to be +20, one to be -20. In this case, my signs are already opposite, so I don't have to worry about that. I'm going to take my top equation. Perhaps I'm going to take my top equation times something. See if I can get my board to work. I'm going to take my top equation times 5. I'm going to take my bottom equation times 4. Again, I don't want my signs to change, so both of these numbers out here should be positive. 5 times -4x is -20x. 5 times 7y is +35y equals 5 times 4, which is 20. On the bottom, 4 times 5x is 20x. 4 times a -6y is -24y. 4 times -5 is -20. So in this case, my x's are opposite. I have one -20 and one +20. They're going to cancel out. 35 minus 24 is 11y. Over here, 20 minus 20 is 0. And when I solve that, 0 divided by 11 still gives me 0. It's okay to have an answer of 0. I want to find my x value. I'm just going to use my top equation. -4x plus 7 times the y value, which is 0, equals 4. Well, 7 times 0 is 0, so -4x equals 4. Dividing by -4, x equals -1. Again, just quickly double checking. 5 times -1 would be -5. -6 times 0 is 0. -5 plus 0 is -5. Yep, it checks out.